Hey, welcome back to the making of To Make It Go. This is my timer 12. I have started it now. And last time I ran into a bit of a snag, not being able to use my proxy way. So at the moment, it looks like I am going to be searching my class for the type that is next. So I can't use request.class, I have to use the actual interface. So, filter. So we need a method, m.getName equals execute. Filter m.get parameter count equals 1. And we want find first. So if we didn't find anything, I'm just going to assume we have one. It's fine. Worst can happen. Actually, at this point, dot map m dot get parameters there we go. Well, I know it's present. Cute. This is going to be the request class. See, it's warning me about that, but I know the method exists because the thing implemented my method, and it exists. And we are going to cast that to question mark extends request. And that's just going to throw a big unchecked warning. But my test passes. And isn't that in the end all that matters? I'm going to take this into a method, find request type. I'm going to suppress that checked warning. And we're going to put that in there. There we go. So now, we should actually be able to cast this guy. That dude needs cast. I'm going to search that result dot get value is whatever it's supposed to be. In this case, it's value. And just like that, we've wired all of that together. Yeah, there's a bug in here with that. To find first. Because I know one exists, it doesn't necessarily mean that the next implementer of one of these objects, an execute object, executable, I believe I call it, yeah, an executable, didn't give themselves another execute method. In which case, that's just going to explode. I will cross that bridge when I get to it. So when I create another execute method and it explodes, and I don't fix it then. See, well, let's see what happens. Okay. Actually, at this point, there we go. Flip that around. There we go. No longer have that problem. Ta-da! I didn't write a test for that, so I feel a little bit bad, but I'm mostly okay with it. Okay. So, instantiate instantiate the guy that I want to handle, find the request, get the mapping. Okay, let's go to our test endpoint and switch to the executing handler. Let's put a public static class in here. Class executor. Implements executable. Executable. Well, it's actually... Yeah, you need to be one of these dudes. Executable? Nope. Did I not make that public? I did not. I didn't make any of this public. There we go. Put that. Public static. Oh, public interface. Request. My request. Let's have public. Do I need public on an interface? String. That's the only thing I support. Get value. Go grab something that looks like that. Make this a string. Value. value. I'll make that a field of the response. Value. Take an construction. Make this dude typed. And I should have get value. Okay, let's build, compile, and see what happens. So we should be able to pass up capital V value, get capital V value out in my JSON response. Oh, this is all very exciting. Yeah, we're gonna have to. One test failed. Given executable method, execute. Wow, that took a long time. Run all the tests. Cute little pointer. It exploded on a null. For request.create. Ah. Yes, it did. We are going to have to do something like this. Get the parameter map. Return. There we go. Run my clean build again. There we go, there we go, there we go. Spawn up my Jetty server. Deployed. Please wait. It's up. Open up my window. Well, this won't work. This is me reading some servlet request documentation. I was checking the signature of get parameter map. I was hoping it returned a list. It returns a string array. Live and learn. And be disappointed. Okay, so this is localhost to make it go. API /test. Okay, we didn't provide a value. Value equals hello. Look at that! I made an echo server. Ta-da! Now, in theory, if I have two, it won't explode. It will return hello. Yeah, there you go. Type test. Value hello. Hooray! It all worked. So now I need to continue to do some type coercion stuff. Which won't that be fun? Okay, type coercion-y stuff. Which is going to actually happen in this guy. The request invocation handler. And my cat is yelling at me. But he doesn't want me to pet him. I don't know actually what he wants. Okay. Make that private, because it's telling me to. There we go. So this guy should be able to do things besides just strings. Because it would be really nice if in my requests I could ask for integer. Something like get ID. That'd be really helpful. So now, let's see if we can do that. Or even asking for a list of IDs, because then I could just run them through, pass them up. Because integers are nice. I should do the same for the 7 primitives in Java and their associated uppercase types. And then I should provide a way of allowing you to define your own so that you can have your own coercion without modifying mine. Yep. That seems like a plan. So step 1. Let's make an interface. Okay. Interface. Invocation handler. We are going to call it a type converter. Not a power converter. We're not going to Tashi Station today. I shouldn't make jokes like that. Okay, so converter. Type converter. Do I want a generic on there? Nah. So it's going to return an object. Convert. It's going to take a string. To convert. Okay. Oh, I said integer. Let's go right at, well, let's actually extract this guy up. Make it public. Let's make an exception for this. Public static class, unable to convert. This is going to extend a legal argument exception. I don't need any of that. Take a message. Like a throwable. I'm just basically going to hit all of those constructors. There you go. So your convert can throw an unable to convert exception, and that will be that. And it'll give us a reason. So we'll let you handle the reasons however you want. However I want. So, step 1. Integer converter. So this is going to implement type converter. I'm going to take a string. We're going to do the simplest thing we can possibly think of, which is just integer.parseInt to convert. We're going to try, because that can throw a number exception format. Catch number format exception. And then we're going to throw new unable to convert exception. Say it cannot be represented as an integer. Oh yeah. There we go. I got him. I got the cat that was yelling at me. I'm gonna scratch his tummy. He's gonna fight my face. Okay. So that's my integer converter. The string converter is going to be much simpler. It's just going to be a pass-through. But now we need to go write that test that says I can do it. I should also test my converter to make sure I can get both branches because, well, I don't know. It'll make me feel good and keep my coverage numbers high, even though that is just the behavior of parseInt. I should still document it. But right now, we're going to make this test fail. Test a bunch of strings. Test invoke with types. Let's grab this. I'm just gonna have an ID list. ID list. Okay, we don't care about any of that. So that my request dot get ID is that's not convertible to an integer. 1, 2, 3. But so right now this is gonna explode. It's gonna be like, what are you doing? Yep, string cannot be cast integer. It's saying, what are you doing? Okay. So let's make a new package to put those suckers in. Converters. Converter. Let's make a string converter for now. That'll be nice. A string converter implements type converter. It's going to just return to convert. Nice, simple. The reason I'm going to do that is because I'm going to come to this guy and I'm going to ask a question. The question is, what's your return type? Because at that point, we're going to have to do some work. So if the return type, so we're going to care about this one first. And I'm just going to be all like, hey, dispatch and do a static mapping of my converters. So strictly speaking, I could make that like an enumi thing. And just walk it, but we're going to just shove it into a map. Class to converter. Yeah. So static hash map class of question mark to type converter converters. We got ourselves a static block here. Put integer.class new integer converter converters.put string.class new integer string converter. We'll make that private, sure. At some point, I may actually want to move that somewhere else so that you can define your own as you go, because I can't tell you what all your conversion types are. Or I could put an annotation on top of the method and be like, hey, is there an annotation present? If there is, grab that converter, use it. And that way, I just have to handle the base primitives, and you can handle any complex formatting you want, and it's just an annotation on top. It's a little bit more junk you have to put on your requests, and I don't know that I approve of that. But at the same time, it gives you more flexibility. It's just another thing to know. So, return type. Oh, converters. Get. return type. I believe there's a compute if absent. And I think I'm just going to return a new string converter. That convert. If I don't know what it is, I'm just going to explode and make it a string. That's a decision I made. Okay. Run my test. There we go. So now, we know you're assignable from list. Get type parameters. I want the 0 with 1. We're going to come over here. And we're now going to ask get ID list. I'm going to make that a list of integers. And we're going to say arrays.asList 1, 2, 3. That's going to explode magnificently because it should just give me no. Why did it give me no? Because it's ID list. This one should explode magnificently. Explode! It is 1, 2, 3, but was 1, 2, 3. And those are lists of entirely different types. Okay. So then, we need to iterate over that list, convert it. So, step 1, can get our type parameter. We're going to system.out.print that because I don't actually know what it is, but it looked like this is how I can figure out what type of generic that is. E. I don't know what E means. Dot get bounds. Run? Not reflected type. Length. 0. We'll grab the 0 with 1 out of that. Okay, we're going back to this. Okay, they're telling me that if I cast it to a parameterized type, all the world will sing my glory. No, that's not true. Also, that was real creepy. I don't know why I said that. Get actual type. Arguments, and that one I want the 0. Oh, that's a big scary mess. Type variable will cannot be cast reflection. Get generic parameter types. What am I doing this off of? Return type. Dot get type parameters. So what is this? You'll now watch as I explore for the next minute if I can even do this. So that's E. I don't know what E means. So what do you have on you? Get name. What is your name? E. Your name is E. Dot get now. Get annotated bounds. Get generic declaration. Dot list. Okay. Do you have type parameters? That looks like a no. Oh, okay. Back to my Stack Overflow article. Look at it. So they're saying that I can also do this with method get generic type parameters. So I have to be up in the method itself, which I have. So method get generic parameter types. And then they're saying that I can do something with that. Let's see what's in there. A little bit of exploration. Nothing. Okay. Generic return type. That's what I want. List. Excellent. That's what I want. Dot get. I have to cast that to a parameterized type. And I can get actual type argument, and I want the 0th one. So that should say integer. Excellent. It did what I thought it should do. So then we go grab this. Want this bit. Wahaha. No, we don't want that. Type converter. I'm gonna just shove that in there. Okay. And then they say that that guy is a class. Okie dokie. Well, that's just terrifying. There we go. Did it work? Wow, that's a mess of things. So there we go. We did it. So now I just have to fill out my type converters, which is a boring task. It's mostly delegating off to things. Yay. There we go. And with that, I now think I should be able to, I can handle integers and I can handle strings. And then I make up my list of things for everything else. Okay, that's neat. Thank you for watching. I went a little over, and this has been To Make It Go.